Hey everybody, welcome to another CUBE webinar. We have a pretty exciting topic today. We're covering combining a semantic layer with an LLM to create an AI chatbot for fast answers. We have Brian and Tony here from CUBE and special guests Mauricio from Quantatec and Josh Patterson from Patterson Consulting to talk more about how they delivered an AI chatbot for their fleet management and customers. And if you haven't joined us before, I just wanted to go over a few quick notes. If you have any questions, please feel free to ask those at any time. Simply enter them into the box, click submit, and we'll get to those questions during the Q&A portion of the webinar. Our recording of this webinar will be available on demand right after the live show on our events page. And if you have any feedback, wait for the survey at the end of the webinar and tell us how we did. We would love to hear it. And what we're going to cover today. So we're going to give you a little overview of CUBE, and then Quantatec is going to jump in and showcase reporting before and after LLMs at their company. Then Patterson Consulting will talk more about the semantic layer and LLMs. And then we're going to show you a live demo of how Quantatec deployed an AI chatbot super fast using CUBE semantic layer. And then, of course, we'll leave room for a little panel discussion and any Q&A from the audience. So without further ado, I'm going to pass it up to Brian to get us started. Welcome, Brian.
Hey, thanks, Nathan. Yeah, as Nathan said earlier, my name is Brian Bickle. I'm the VP of Strategy and Alliances here at CUBE. Really happy to be joined today by our friends at Quantatec, who we're really excited to see their usage of CUBE and they're kind of growing with us as a customer. And also with a good friend of mine, Josh Patterson from Patterson Consulting, who's been at the forefront of doing some really interesting things with LLMs and semantic layers. So as Nathan said, I'm going to get started today by giving you guys a little bit of information about what CUBE is if you're joining us for the first time, and then I'm going to get out of the way and get to some guys who are more interesting than I am to tell you how to do this stuff in practice. So if you're not familiar with CUBE, CUBE is a universal semantic layer, and when we talk about what we do, we think about our mission as powering the next generation of data-driven applications. And we do that by trying to make cloud data more accessible and consistent for every use case. To really click on that and talk about the three sort of main use cases that we see people selecting CUBE for, those sort of fall into camps of embedded analytics, and that might be customer-facing dashboards, or that might be adding reporting to some kind of application or a data app. Situations where you're doing multi-BI and you're connecting multiple BI tools, and you're really more focused on consistency of metrics, consistency of security and caching, and maybe connecting multiple databases to multiple BI tools. And the use case that we're going to talk about today and really focus on is this emerging use case of AI-enabled chatbots and AI agents and work in that area. To talk about CUBE and sort of like the moment that CUBE exists in and like why we built the company, we're in this situation in data where, there's not really a winner take all in terms of data warehouses. There are cloud data warehouses running around, things like Snowflake, which are quite popular. There are data lake houses like Databricks. There's, people using relational databases and wanting to query those directly, and that could be a Postgres or MySQL or something like that, all the way to like a long list of exotic time series databases and fast analytical databases, things like ClickHouse. CUBE is really trying to help people manage the many-to-many chaos between all of these systems that we can look at on the data source side, and then all of the consumers in the enterprise that are doing more and more things with data now and doing them in unique ways that we hadn't seen before, like such as embedded analytics and connecting multiple BI tools, connecting AI agents, and the use cases we just went over before. But the real trick of what we're trying to solve is to really keep users from having to repeat themselves by defining lightweight data models in all of these downstream applications over and over again. through the usage of a semantic layer, you can apply model consistency and apply security consistency and really make this experience one that's more manageable and easier to produce consistent results with. So to click down into the Cube platform and exactly sort of what's in the box, we talk about Cube in terms of 4 main pillars of functionality. Every semantic layer brings a data modeling capability. That's sort of like the thing you have to do if you're going to call yourself a semantic layer. Cube's data modeling capability is a code-first experience that is easily version controlled. You can select YAML for that, JavaScript for that, Python. The Python gives you some nice scripting capabilities, so does the JavaScript. You can really do some nice dynamic data modeling capabilities. Things that are quite complicated become actually pretty easy in Cube to do at runtime. In addition to that, we provide a robust access control scheme that lets you do some clever things like column level masking, row-based security, row-level security, role-based access control, and really do some nice multi-tenancy things if you're building a embedded analytics situation and you want to really ensure that user A and B don't see each other's data, or that you don't influence user A in any way by the state of user B's environment. That's all done through JOT tokens and a really robust security context model. And next we have our caching functionality, which is proprietary technology that we built called Cube Store. That is a very fast pre-aggregation engine and 2-tiered caching scheme. We do aggregate aware pre-aggregation in Cube, which is a nice feature, meaning that if you have an aggregation at like a specific time grain, whether that's a day or a week or a month, you don't have to let your BI tool know about that. Cube will actually rewrite your queries for you to select the fastest pre-aggregation that we know about. And that's something that we do to help the BI developer or the application developer not have to deal with the complexity of caching. And finally, everything leaves Cube via our different APIs. And we provide a REST API, GraphQL API, and a Postgres compliant SQL API for all of our downstream connectivity. If you're trying to think about maybe like why you need a semantic layer, we would really point to these sort of major benefits. Through the data modeling, we get better data consistency. As I mentioned before, one of the things that has popped up with multiple BI tools in the past is that they each tend to have their own lightweight semantic layer, where maybe you're defining a data source, you're defining calculations or a data model. If you have many of these BI tools and you have an embedded analytics solution, also, you're going to run into a situation where your models will disagree, or maybe you're producing some kind of inaccuracies because of that. So semantic layers can help resolve that. They also provide some benefit in terms of security by building a consistent security model that every data experience connects to. Performance can be improved by our 2-tiered caching and pre-aggregation system. And these last bits, I can kind of all loop into this idea of developer productivity and developer experience. If you have a semantic layer that sort of disintermediates your data sources and all of your downstream experiences, then swapping a data source out in the future is much easier. Adding additional downstream tools is much easier. You don't have this sort of migration challenge that you have if you're stuck in like a single BI tool or in multiple BI tools. And then also, Cube provides some amount of time to value and future-proofing benefits in the same vein. Now, if you're trying to maybe orient yourself as to like where semantic layers sit in the modern data stack, we're typically adjacent to the data sources like a warehouse, lakehouse, time series database, query engines, all of those things. We don't do transformations. We're sort of just at the same party as transformations is what I like to say. And then all of your downstream tools would eventually connect through a semantic layer. And really to set the stage for AI and then to kind of hand it over to our speakers today, in this sort of emerging case for semantic layers being in the mix of building AI chatbots, we find that if you're trying to do something like build a natural language query interface and maybe you're using text to SQL as the operational model, the LLM generating raw SQL and running it up against the database tends to produce a lot more errors and inconsistencies and things like hallucinations of columns that don't exist or of metrics that are calculated wrong. And what we found and some other researchers have found is that if instead you have the LLM generating requests to a well-defined semantic layer with constraints of what metrics exist and an API spec and maybe even querying it via REST or graph instead of generating raw SQL, you tend to get a better experience. So that's something that we believe in, but is sort of emerging, and we're interested in working with customers on that right now. And with that, I'm going to go ahead and pass it over to Mauricio from Quantatec.
Hello, everyone. I'm Mauricio from Quantatec. I'm a project manager there. And I'd like to speak about how we are using Cube to solve many of our issues that have appeared to us. Just like Brian said, we are pretty much using everything Cube has to offer to us so far. So speaking briefly about Quantatec, we are a resilient company specialized on the fleet management market. So we design, manufacture, and deploy tracking devices for vehicles, cars, trucks, and bikes. And also we provide to our customers a fleet management platform. And this is what we are going to talk about in the next slides. So one thing that our fleet managers, our customers wants to see is reports. They want to see how much fuel they have used in a month. They want to see how many miles a car has traveled that week. And every time a customer asks for us a report, in the old way, what we have to do. The customer will access our website, see a predefined report there, make some filters like selecting the cars or selecting the drivers they are interested in, select the time range, and it will generate a SQL query to our database. This query will return some results, and we will present a nice report to our user. Sometimes this takes long because the database is receiving a lot of requests. It's also processing all data that's coming in real time from thousands of tracking devices in the field. The customer gets frustrated. Also, the customer wants something new. So they call me and say, hey, Mauricio, I want to add a new column on this report. I want the driver's name there. Or I want to add the fleet name on that report. And we need to rewrite that report to generate that kind of thing to him. It takes longer to deploy. We have a long task queue to realize that and make everything work to our customers. So the beginning of last year, we started to look for tools that could help us on that. So another customer asked us for a live dashboard. They wanted something visual, and that could be updated in real time. And we developed that for them. And we saw that it was just the beginning of a major issue that we were going to have. Other customers would like their own dashboards, querying their own data, and everything was going through SQL queries on our Postgres server. We are going to have performance issues and a lot of engineering work to customize every dashboard. So we found Cube and we started developing the live dashboards. Why have we chosen Cube? At first, because of the pre-aggregation caches. Their capabilities of aggregating data and returning that to the user pretty fast was amazing. Everything goes to Cube and almost anything comes back to our database. Cube can manage those caches very efficiently. So we designed a tool that the user could draw their own dashboards, because this is also a requirement we have. Fleet managers are not programmers. They are not aware of how the database is organized, or how tables are related to each other. They can't build their queries themselves. So we needed a graphical tool that the user could just select the fields they want, the metrics they want, and plot the data in time series chart or a bar chart or whatever chart they want to see the data. So in a matter of a few weeks, we developed these dashboards, and the performance was really nice. It was what we were expecting to. And also, we were using multi-tenancy. That's a feature that Cube provides to us, and it's very important because on our database, we have data from hundreds of customers, and they can see data from each other. What we asked for there is if a user is asking for some vehicle, they cannot see data from a vehicle that does not belong to him. And Cube has this capability on the query he writes, functionality that provides row-level security to our database. So the customer is making the same query. Every customer makes the same query to Cube, but the queries are rewritten in a way that filters out the data that they are not allowed to see. And as I said, due to the pre-aggregation caches, most of these queries are not even hitting our database. They are resolved directly by Cube, providing a very nice live feeling from the dashboards. Well, in the meantime, we met Josh, that's going to talk to you soon. And they showed to us a demo of a chatbot that could answer questions based on your data. By that time, ChatGPT was being released for everybody, and we thought about ChatGPT as something that we could talk about the past, the human knowledge in general. But he showed us a different perspective where we could make ChatGPT to answer questions based on your own data. So we started working together, and in a few weeks, we developed a chatbot for our application where the user is asking a question. This question goes to our service, to our agent running on Kubernetes service in Microsoft Azure. This service builds a SQL query using OpenAI API and the LangChain framework. This query returns to the service, and the service queries Cube to fetch the data. Most of the time, due to Cube caches, those queries do not hit our database. Some of them may hit because the user can ask whatever they want. So sometimes there is no pre-aggregation cache available, and it will hit our database. But in general, most of them are cached in Cube. And now what we have is not something that the user needs to know how to program, such as Power BI or other tools. It's not something that the user needs to draw a dashboard, even if it's easy and nicely to view. The user just asks a question and the system will return the answer. For fleet managers, board directors, this is a game-changing capability. In the end of the day, they want the answer to answer their questions. They don't want to look through reports. They don't want to find data or fetch data on dashboard. They want to ask, who is my worst driver? How much fuel have I wasted this month? Or this kind of thing. Using LLMs and the power of ChatGPT, we are being able to deploy that very efficiently thanks to the semantic layer we are using. Okay? So this is the state of our system now, and I'll lead you to Josh, that will talk more about the concepts behind the scenes, and later I come back to demonstrate that to you.
Hey guys, I'm Josh Patterson. Thank you, Mauricio. That was an awesome story. Yeah, it was fun getting introduced to Mauricio, and I remember the first time we talked about doing a dashboard with our team. I kind of half jokingly said, "Well, what if you could just talk to it?" And Mauricio kind of smirked, and he's like, "Well, that sounds great, but do you have a demo?" And then we did. When we showed him the demo that we did in Cube's booth at Snowflake Summit, where you could talk to an analyst. that did analyzing scenarios. And then he goes, okay, that's great. Make it talk in Portuguese. And then I just kind of tagged on, and I didn't know if this would work. And this was kind of funny that it did work. I said, answer in Portuguese. And then like it did answer it in Portuguese. And I had to look at Mauricio and be like, is that right? I don't know. I can't read Portuguese, you know? And so that's when he was like, yeah, I think this might be interesting. Right. So at Patterson Consulting, you know, what do we do? We're a boutique SI. If the large SIs are, you know, the Army, we're the Navy SEALs. And we focus on next generation technologies such as machine learning, data engineering, large language models, and the infrastructure around that. And if you want to know more about our philosophy, you know, check out our ebook on knowledge versus reasoning, which is foundational to, you know, I'm going to talk a little bit about the underpinnings of how we pulled off this. Foundationally, in the world of large language models, you have knowledge, which is in your, you know, your data warehouse, your time series database, or Postgres, as in Mauricio's case in Quantatec. And then, you know, large language models are not databases. They're good at reasoning. You know, if you go look at the theories such as Yao Fu, he talks about in his publications, you want large language models to focus on being good at reasoning. Don't ask them to recall specific facts. Hook them to knowledge repositories such as databases or vector databases, and let those be good at what they're good at, such as recalling specific facts. Hook them together, and that is where retrieval augmented generation lives, in that place where you have decoupled knowledge and reasoning, and then you hook them together. And we have more about that. We'll talk more about that here in a minute. We have some nice blog articles to leave you guys with, and gals. So, you know, retrieval augmented generation, a lot of people talk about that these days, and you see it on LinkedIn a lot. We just released a blog article, which I'll link here in a minute. But what is that? And generally, it's a phase where you have an agent behind the scenes who goes and retrieves relevant information on how to answer a question from the knowledge repository, right? And then it augments the question or the prompt to send it to the large language model for generation. Now, what does that mean? Retrieval, that means get information relevant to the question, to the user, to the context, to the scenario, and implant it into a larger prompt. Prompt is just a body of text where you ask questions or make statements or ask for tasks to be done, and you insert the relevant information through augmentation into the prompt. Say, you know, in this case, it might be trucking records for the current user that are relevant to the prompt. And then in that body, you send that whole payload over to the large language model. And then it reasons over the text and then the data together to generate an output. And then the agent parses that output. Now, this is where I think Cube really shines. If you put a semantic layer in front of your knowledge repository, you can do some neat tricks. A, you have, like Brian was talking about, you have a unified API. B, you have user management story like Mauricio was talking about, which they love Cube for, in terms of being able to manage, you know, partitioning out different customers' data. And then I think the other thing that I really love is you can put better quality metadata on top of data models that are relevant to large language models, more so than you can with traditional data warehouses. So we use that a lot under the hood in our augmentation phase. So when you do all of those things together, it improves the retrieval augmented generation process under the hood. So, you know, kind of going back to that diagram you saw a minute ago with Brian, where you had where does the semantic layer live, separate from the transformations, data warehouse. You know, the LLM agent is looking at the semantic layer, which is a view of what's going on in the data warehouse, what I was talking about a minute ago. And then when it looks into there, it can reason about if you want it to write your query for you, and in some cases it wants to do that, we can put better quality descriptors on, you know, the cube, on the dimensions, and so forth. And this really, really helps LLMs write better queries. Now, In this case, we don't always want the LLM to write queries for us because that leaves room for error. A lot of times I think you see people when they build LLM applications, they complain about hallucinations, which is when the LLM just says something crazy and then it messes up your application. What we do at Patterson Consulting is we have a prompt analysis agent. We have pre-steps before you hit the actual part where you answer the question. And we like, what type of prompt is this? What type of question is this? And if we know that the user has 10 different reports, such as like Quantatec, we'll route it to a specialist agent who just focuses down on just that type of report. And it has all of this tribal knowledge within the enterprise on how to answer that report. And that, and it also has different commands around how to think about variability in the question and, different how to pull variables out of the question to build better meta prompts to pass the LLM, downstream. So our prompt analysis agent is some of our secret sauce, and then our specialty multi-agent systems are some of the ways that we are, building next generation AI agents these days. So, if we've talked about building meta prompts, this is what an augmented prompt would look like under a hood. You always want to tell, philosophically, we found that you want to treat LLMs kind of like they're junior analysts, and you don't want to give them too many degrees of freedom. Like if you try to let them just answer very wide-ranging analytical questions, sometimes they'll get confused. But if you tell them they're a smart logistics analyst and they're great at answering questions about trucks and logistics, you always got to be nice to LLM. It really, really helps. And then you got to also tell them if you don't know the answer, admit you don't know. All right. And these things, you think that sounds silly, but the LLMs really like to hear that. And I gave it some context. The speed limit is 65 miles per hour. And then the augmented context we might have pulled from a system such as a data warehouse or Cube would have been a block, like a block of records. And then we just converted it into a CSV format and dropped them in there. And then added a question at the bottom. Which trucks in the fleet above were over the speed limit on average? And that would give us the answer we're looking for, which may be very abrupt or it may be long and verbose. And then we might do something like a post-processing on it to say something like truck 8029 was running above the speed limit of 65 miles. That should be miles per hour, not miles per gallon, on average, right? And that is a quick walkthrough of how we would generate a report. Now, there's a lot of tricks under the hood around how we do prompt, different types of retrieval augmented generation tricks and prompt analysis tricks, but that foundationally is what it's about. I think, what we're seeing now is there's a lot of interest in terms of what you can do with these agents, and there's a lot of tricks on how to do it correctly. If you want to have a fun brainstorming session, check out what we showed off on our demo reel at AWS reInvent 2023. There's 7 or 8 different domain applications such as healthcare and insurance and so forth that you can walk through that video. And if any of that looks fun, maybe give Brian or me a call and we'll talk further. With that, I'm going to hand it back to Brian.
Hey, thanks, Josh. Yeah, I guess Mauricio, were you going to go through a demo and show us a little bit of what you guys built, what you're able to show us?
Yes, sure.
That sounds great. Yeah, thanks.
Yeah, no problem. Let me start my screen sharing. Okay. I think now everybody's able to see it. Okay. So this is Node-Wave report. So the customer comes here, select the date range, select the vehicle they want, and they want to see the history of fuel consumption. Our platform is Portuguese, but I will guide you through this. So the click here, generate report, and the report is there. Okay, it was fast because I have just made it, so it's this issue on the Postgres cache. Okay, but if the customer wants something different here, for instance, this table, oh, I want to add another column here or something there, we had to rewrite this report, which was very annoying to us. And we started develop the dashboard, as I said, and this is a dashboard of my fleet. It's just some cars that we have to test. I go through something from our customers to show you some live data too. And this kind of report, this kind of dashboard is very easy to create. You can click the button, you select the type of report, for instance, bar chart, select some metrics here. And all of this has been modeled in Cube. And we can see how easy it gets for the user to build their own thing. Oh, I want my panel of this kind of thing. The panel goes over there, and it's easy to use. Okay, but if the user wants to see something very specific here, they need to filter by the vehicle. They need to filter by clients, and this is what I was talking about, multi-tenancy. I am a super user on the platform, so I can see things from all different clients that we have, but a regular user cannot do that. And this is something that cubes help us a lot by rewriting the query. What we are doing behind the scenes is that we get the user, we know which vehicles they are allowed to see, and then we rewrite the query, adding filters to the where clause, removing the vehicles they are not allowed to see. And this is nice until we met Josh and we developed this chatbot. I'm gonna open here my console just to show you something interesting, okay? So I'm gonna ask here a question about my vehicle. I'm gonna ask it in English so you can understand, but the chatbot has been trained to answer in Portuguese. So let's see how he's behaving. How many kilometers vehicle FTI estimated, which is my car, has today? What's beautiful is that I have some syntax error in my English here, but it can understand and it has answered in English. Now let's see the query it has been built. ChatGPT has returned this kind of query to us. So select the total distance traveled and filtering by the vehicle's plate, which is the one I provided. And I said today is January 24. Everything is working very well here. And this is something that Josh was talking about. When we design the model in Cube or whatever semantic layer we're talking about, it helps a lot the AI if you give meaningful names to the columns. So I'm not telling anywhere to ChatGPT that trips.total distance travel means distance traveled, but it can get it from the context. If I ask for fewer, for instance, so now I have not said to him the plate, but I believe he can understand from the concept. From my previous question, it has found that FTI 1518 is my car, and I have used 1.1 liter of fuel today. So this is nice. It has rewritten a different query based on our schema, and selecting just the columns that it needs to be selected to answer the user question. And everything else works perfectly. But we are not seeing here a filter, for instance, about the vehicles I'm allowed to see. I'm asking for FTI 168, that is my vehicle. But if I log in here with Rafael's account, which is a customer of mine, and I ask, how many kilometers has the vehicle FTI meeting traveled today. I do not expect it to answer this question. So I'm sorry, I could not find this information. Obviously, because this is my car, it's not Rafael's car, so he has not access to it. And who is doing that? The query is still the same. Cube is doing that behind the scenes. He's writing this query, adding a where clause here, filtering out the cars that Rafael has access to. So this is the power of combining the semantic layer to ChatGPT. If we could, we had to train ChatGPT to, hey ChatGPT, I'm Rafael. I can only see these cars. The prompt would be a mess. ChatGPT is artificial intelligence, so it's not deterministic. It could understand what I'm asking to, or it could just ignore it and return the information. We need to make sure here that a customer has not access to data from other customers. And when we put that on the semantic layer, we are writing deterministic code to filter out this and completely avoid this kind of mistake. So something that we could also ask, who is my worst driver this month? So now it's going through all Rafael's cars and finding the worst driver. So Angel Asuncion is the worst driver. He had 15,000 negative events. We can see the query here that it has added driver is not new because sometimes the driver does not log in. So it commit some overspeed events or something behaves badly with his car, but we are filtering out this kind of thing here. And as I said, this month, it has built from January the 1st to January the 24th. This is the beauty of the power of ChatGPT, how smart he is to build these queries for us. So if I ask him to describe such events in a table, let's see what we get. We get an error here. So context length exceeded. Sorry for that. We have a limit on the number of characters we need to put. So I will do again here, describe the events from the worst driver this month on table. This is something that we need to be aware of. ChatGPT has a limit on the amount of characters that we are prompting to him. And the problem of this thing is that when we have the history with several questions, we need to summarize it in a way that keeps the limit of characters within its capabilities. So here he's describing on a table, as I asked. It has changed the login here from Mauricio, so we are not seeing the Angel Asuncion again. But it did what I asked. I'm seeing the data on a table, all the kinds of events like harsh acceleration, harsh braking, harsh cornering, overspeed, over RPM, and whatever we have there on our database. Okay, so this is what I would like to show to you guys, how powerful this kind of feature is, how powerful it is to combine both an artificial intelligence with a semantic layer, how a semantic layer enhances and solves several problems that ChatGPT could cause. Hallucinations is one problem. It could create a query that does not follow all instructions you provided. It could not filter the data from a customer that he's not allowed to see. And when we put that on a semantic layer to intermediate the questions that goes to the database, we can actually fix the queries that have been generated by the ChatGPT. So this is the demo I would like to show to you guys. I hope you have enjoyed, and I'm here to answer your questions if you have any. I'm head back to Brian. So thank you very much for your time.
Hey, thanks for giving us a demo, Mauricio. Really appreciate it, and it's great to see how you guys have been able to, as you said, kind of use a lot of different features of Cube in your solution. So really appreciate you going through that. Yeah, as Mauricio said, we're going to open it up for questions and answers now. So if you guys out there have any questions, let us know. Drop them in the Q&A, and we will answer them as best as we can. I did want to address one thing. We have a lot of questions about whether or not the presentation is being recorded. It absolutely is. We will have it available as a video on demand on the cube.dev website. You should just be able to go to cube.dev and find the events page in the top nav, and then you'll be able to find the speaker information, all the information about us, about the summary of the content, and then the video on demand later. So with that, I am going to go ahead and dig into some of these questions. We did have a question about some of the core Cube functionality. A viewer asked, what does it mean to query rewrite to support multi-tenancy? When I was talking about the general Cube functionality and security context under the access control pillar, as you can see here in the diagram, I mentioned that we can do query rewrites. And query rewrites can be really useful in a multi-tenant situation, like what Mauricio was talking about in their application, where you have maybe one data set, you have multiple customers in it, but you don't want to change your dashboards to be specific to each customer and manage that. You want to do it in a highly dynamic way, and you want to do row filtering based on the security context and based on the user that's authenticated. Because Cube is a complete runtime and has the ability to take the API request in any format, apply the security context of who's logged in, we can then rewrite the query back to the underlying database or to Cube Store if we're hitting a pre-aggregation to make sure that we apply that filtering. And we do it in a really secure way, and that we can make some guarantees about it working. So that's what we mean when we say query rewrites. And there are also other things you can do. I mentioned before, things like column level masking or obfuscation, or different things especially with the Python interpreter. You can get quite complicated. There's another question here. Somebody asked, is Cube applicable to on-prem data ecosystems? Cube Cloud right now, primarily, most customers are connecting to cloud sources, although we do have some bring your own cloud offerings. And if you are interested in talking about interoperability with on-prem data ecosystems, I would encourage you to reach out through our Contact Us and chat through that with us, and we can talk about some resolutions to that. Let's see what else we have here. This is a question. I think this is going to be more about the actual implementation at Quantatec. So I had a user or a viewer asked, do you use security context or filters to apply rules? Mauricio, I think, yeah, go ahead and talk about that.
Yeah, sure. We use both. Using the security context, we can get the user that he is making the request. And based on the user, we go back to our database, fetch the vehicles or customers or drivers, whatever that user is allowed to see, and add filters to the query rewrite function that removes those elements from the original query.
Okay, great. There's another question here, and I think this is going to be about just the general interplay of the LLM and the semantic layer. But a viewer asks, how is it able to determine which table to run the query against? And if it starts to choose incorrectly, how could it be trained to stop doing that? I'm going to address this maybe at Josh, and maybe do you want to talk a little bit about how your approach to agent building sort of helps mitigate that?
Yeah. So sometimes if you just let an agent, if you just point the agent at like all the tables and say select the table and write a query. If you point it like a traditional database, typically you have challenges with like the DBAs don't have senses of humor, and they typically will name tables, TXN 2018, and the LLM's like I have no idea what that is. So if you can take a semantic layer and then give it more English names, like just not English, but full natural language names as opposed to DBA names. That helps LLMs a lot in terms of figuring out which table to use. And then if you give each of the column names is very, very verbose natural language explanations, that helps it a lot too, to reason about what columns it should use and how the columns are going to relate, right? So that is one trick that we found was just out of the box. I was just like, let's just go start giving, natural language names for everything. And it just helped. It helps, classical data, DBA stuff work better with LLMs. And then we found like sometimes we knew based off the prompt, if we just did some prep analysis, we knew what kind of question they were going to ask. And so we just did what's called prompt router, which is really a prompt classifier. And then if we were like, well, this is a bad driver report. Once you know that, there's no sense in asking the LLM to go look through all the tables, figure out where the bad driver data lives, et cetera, and so forth. What you should do then is just route it down to an agent who knows how to write that report and just say, this is a bad driver report. You're a bad driver specialist. You know where the data lives. Here's which means they'll have a template for the SQL statement, and then analyze this prompt with LLMs to figure out what the variables are that you should pull out and plug into your template, right? So it's those two pieces in conjunction at different stages of application, depending on how many degrees of freedom you need for that sub-agent, is how we pull off those tricks and how you're able to let it, reason about where, which table and what type of query it should be.
Cool. Thanks for the answer. We've got one in here. This is actually kind of an interesting question. This is about the intersection of LLMs and generating cube definitions. So this is maybe LLMs in a different context, but the viewer asks, are there any tools to leverage LLMs to generate cube definitions based on inspection of schemas in the database as a starting point? I'm actually going to let Tony answer this, and he's going to talk a little bit about what we've been up to, and then maybe I'll provide some color commentary.
Yeah, I think the cube data model generators, the place to start, right? As you're building your cube model, that's kind of the first thing as soon as you connect to your data source. And that's getting better. We're putting a lot of effort into improving that process, and I wouldn't be surprised if eventually we're asking LLMs to make those to do that introspection for us. But yeah, for now, that's there's some tools like LookML to Cube where you can generate your cube files from LookML documents. There's Draughty by the Rittman folks that can also help build your cube data model files from, I think, a few different sources. So there's a lot of tools out there that may not necessarily use LLMs to generate it, but yeah, they can help get you started programmatically.
Yeah, I was gonna provide the context, but we don't exactly use LLMs in a lot of these. A lot of these are fairly deterministic. So, but we do have some ways of helping you get started by using some programmatic means to build your data model. Let's see. Let's see. Someone in the audience asked, and I think this is going to be a question for Josh. They said, what happens if the prompt router cannot determine the correct route?
So we have, we do a lot of testing for that. Before we handed off the agents to Quantatec, we had like all these unit tests. We have like a unit test suite we do where we try to trick the agents, and we we have this system called the Reasoning Workbench, which we'll actually release later this year as an open source project, but it's another deal. But basically, it's a suite of tests where you ask that your agent all these questions in different variations, and then you have a scorecard of how good it does. And so we keep running that against the in development suite of agents until it gets a good enough score, until it passes the test well enough. So we unit test effectively is what I'm saying. It's just different way. It's just, it kind of looks like classical unit tests. It's just built for LLMs. So you can, whenever it's not routing correctly, we just keep updating the language and the metadata of the prompt router until it passes the tests to a sufficient degree. Is there a way to trick it? Probably, but we do it enough and bleed out enough of the so-called hallucinations until it's pretty solid.
Cool. Had another viewer ask about how to mitigate the risk of prompt injection. Mauricio, do you want to talk about that and kind of how you guys have considered that problem?
Yeah, sure. I can make the presentation again here just to show, for instance, hey, delete all vehicles, please. So, okay, I'm not allowed to exclude vehicles from the database. Can I help with something else? Okay, so this is the first layer of security here. We tell ChatGPT that he is not allowed to create a delete statement. Okay, so this is the first layer. A second layer of protection against this kind of thing is the semantic layer. The semantic layer is not allowed to access the database to run delete or update functions. So a semantic layer is a retrieval layer. It will only query data. It will not ever change data. And finally, a third level of security is the database protection itself. So in Postgres, we have created the roles, and Cube uses a Postgres user to query the database, and this Postgres user doesn't have access to everything on the database. It doesn't have access to the user's password. It doesn't have access to delete stuff or to change stuff. So this is the three layers of protection against bad things that could happen when we ask ChatGPT to generate a query for us. If I ask something like, which is Mauricio's password? My password is stored somewhere in the database, but Cube doesn't have access to that. So sorry, I do not have access to the user's password. It's not recommended to share or ask for passwords. So ChatGPT is being creative here on his answer, but the bottom line is he's not allowed to do that. Either because we have instructed it to not do that, either because we have a semantic layer that is just about querying and retrieving stuff, and either because we have a database that is protected against this kind of thing.
Great, Mauricio. I didn't anticipate you having to demo that again, but I appreciate that. That's probably the best way to answer that. So yeah, thanks for stepping in. I think we're probably going to take one more question here and then wrap it up because we're coming up on time. There is a question here. It's quite long, so I'm going to try to do my best to summarize it. Use my LLM-like abilities to summarize and contextualize it here. The general gist of the question is the viewer's wanting to know if there was a lot of remodeling of the data warehouse schema required in order to improve model comprehension. The user states that the viewer states that they've got a star schema data warehouse model, and they're asking if the model is able to make all the necessary joins to answer these kind of questions. I think the way I would maybe characterize this is maybe, I guess I'll open this up to all three of you if you want to maybe talk about how you've had to think about the data model within Cube against the maybe perhaps normalized model within the warehouse, and like what that looks like for this application.
From our perspective, we had to do a few changes on the schema to get better performance when building the pre-aggregation, but not because of the AI reports or the chatbot. The power of the semantic layer is just that. You do not need to change your database. You can create a semantic layer that will create the columns, the dimensions, the metrics that you want based on a very complex database that you may have. So when ChatGPT is looking to the model, it's not looking to your database model, it is looking to the semantic layer model, which is kind of simpler. Should be very easy for him to understand the schema that you have. And as Josh said, we have prompt routers that can, based on the question, direct the specialized agent that's going to build the query. And that agent has knowledge about some part of the model, not the model, the whole model itself.
Yeah, I mean, I'll add to that. A lot of times if it's a complex join, I mean, I go back to how I talked about you treat the LLM as a junior analyst. And if you're like, hey, junior analyst, go pull all the 2018 transactions for this subset of the company, the junior analyst is probably going to look around and get confused because there's lots of tables and it doesn't know, that person, he or she doesn't really know where to find stuff, you know. But if you constrain their field of vision down to a more simple problem, they're typically able to solve that problem. And you need less reasoning horsepower to do the simpler problems. So that's where we'll do a combination of the prompt routing to get the problem space constrained down. And then we will let a specialized agent use the semantic layer to get the knowledge that it needs to augment its prompt for the reasoning, right? And that's where, you know, the combination of the prompt routing plus the semantic layer really shines in the retrieval augmented generation framework, right? Because then, like, if you call the data warehouse people and be like, I want you to change all these tables, they're going to tell you to go, you know, go fish, and that's not going to happen. But if you can make tweaks in, you know, the semantic layer land, you can make all sorts of views or data models specifically just for the agent and have a lot of metadata just for the agent. And that's where, you know, those really wacky joins that you may need, you just constrain down the problem space, pre-compute a bunch of stuff, and then the agent, it makes the problem simple enough for the agent to pick it up.
At the Josh mentioned it too from the views perspective, but there's the cube layer and then there's the view layer in cube, and so the cube layer would have your joins and your calculations, and then the view layer is basically selecting, you know, hand picking those fields that you want to include in the presentation layer for the data. So that's one way to provide that context and simplify the output.
Awesome. Thank you guys so much. Thank you, Mauricio, and thank you, Josh, for joining us. That was such a great discussion, a lot of lessons learned. So I appreciate you joining us today. For all of you, if you want to learn more, dive deeper into Cube Semantic Layer, Quantatec, and how they work with an AI chatbot, and Patterson Consulting, learning more about LLMs. Make sure to check out our resources. You can see those right on the platform, and we'll also share the stack so you can go into the presentation for review. A couple call outs. If you want to check out Bring Context to AI Chatbots and LLMs from Cube, double click there. You can also learn what Quantatec does through their website. And then lastly, Josh wrote some pretty amazing blogs, the evolution of retrieval augmented generation blog, as well as building natural language user interfaces over analytics applications. Check those out. They're available on Patterson Consulting's website, and they'll deep dive into what we talked about today. All right, thank you, everybody. Hope to see you again. Have a good day, night. Till next time. Bye.